Anyone who lives in America could probably tell me where your nearest Best Buy is. In fact, you could probably tell me where your nearest 3 Best Buys are. Where's your nearest Target? Everyone knows where their nearest Target is. Where's the nearest McDonald's? What we're trying to do is create charging infrastructure in places where people work, shop, eat, and play. We want to make these destination locations. When you go for a level 2 charge, that's a full charge in 4 to 8 hours, you're going to have to stay there for at least an hour to get anything meaningful out of it. So you got to do something for it. So we need to match up the level 2 charging destinations with the appropriate commercial host to ensure you're in there. The average stay at a Best Buy is 42 minutes. They put Xbox stations and PlayStations there so that kids walk in there and stay longer and people purchase more things. Having someone there for an hour to charge their car makes a lot of sense. I contrast that to a BP or an ARCO. Average stay at a BP and ARCO is about 8 minutes. They also want people to go in their convenience store, purchase more coffee, purchase more Diet Coke, whatever it may be. So again, that would make sense for a BP and ARCO station to have a DC fast charger. IKEA, Destination Spot, ARCO, Kroger, Fred Meyer. So we're looking at these supermarkets, we're looking at big box retailers. We've also been installing chargers at Walmarts and McDonald's throughout the country as well. So you're really seeing corporate America step up to the plate and say, I want to understand what this is like. I believe that an EV driver is going to be a higher demographic. I believe that the EV demographic will be similar to a hybrid user. That's the type of A-plus demographic that corporate America wants to see come to their retail locations. So that's really what we're trying to do. We believe that if we can build a national network with shopping malls, national retailers, commercial property owners, that's really how this is going to start. If we can prove to them between now and the end of 2012, that's when, or actually middle of 2013 when our project ends, that not only can we effectively and efficiently deploy infrastructure to your location, but you're just going to see a return on that charging station. Let's say a 3 to 5 year ROI on that charger at an 8% rate. That you're going to get a high quality tier demographic that's coming to your store, spending longer there, and hopefully getting more high margin SKUs in their shopping basket. That this makes a lot of sense. So when we need to go to Akron, I'm going to go and ask Best Buy and IKEA, let's make you guys the base camp for charging in your area. Let's build around these core locations and let's make sure that brand identity is associated with sustainability and as a destination spot for EV drivers. So that's how we're tackling the siting of this. But we need to be a little bit more pragmatic about that. What we need to understand is that entire value chain. This kind of Homer Simpson utility plant here is supposed to be a utility control station. But working around, we're seeing commercial areas. We highlight the home and the smart meter interaction, gas stations, street side charging, employer locations. These are all part of the mix. And what we can't do is we cannot use federal funds frivolously. We need to understand exactly where to put charging stations, what type of timeline, and why. So we're looking at traffic patterns, we're looking at population densities, destination locations, and we're doing that through what we call our EV microclimate program. It's a very kind of holistic turnkey program where we go in there, we pull together local stakeholders, utilities, we sit them down and we say, what do we need to do in this area? How are the building codes structured right now? What is the deployment process like if I need to install a charger? How do I permit and certify the installation? I can't be in Carlsbad and it be a $20 installation and then go to Escondido and it's a $400 installation with a 4-week lead time. The consumer experience there isn't going to work. So how do we streamline those amongst cities, counties, and any type of jurisdiction? Then we look at where we're going to put them. It's pretty easy to see where you think these vehicles are going to go. We're looking at demographics, age, travel patterns, you name it. So we create a map all the way out to 10 years. And we say in 10 years, these neighborhoods, you're probably going to see a lot of EVs. These freeways, these interstate areas, you're going to see a lot of population of plug-in electric vehicles. So we create that long-range plan, and then we boil it down to about a 2-3 year specific action plan with this is where we should put chargers. These are exactly the spots that we believe EVs will congregate, and this is where consumers are going to need to charge their vehicle. It just so happens that national retailers take this same type of consideration when they figure out where they want to build their shop. So you're seeing that these Macy's, these Best Buys, these Walmarts are all in these very high traffic locations. Additionally, they oftentimes have ample amounts of power or nearby transformers just for that facility that we can feed off of, which, depending on where they put their charger, can reduce installation costs. But we are seeing a lot of these retailers only right out front, which means it's 150 feet of conduit, which is a little pricey. But what we are trying to do is kind of be that clearinghouse and pull together all the different stakeholders in this microclimate process, galvanize the troops, and make sure we are deploying infrastructure accurately. Here's an example of what we do in this project, of this task. I'll go from left to right in our microclimate program. The left side there is exactly how you deploy it. Where does the EVSE be located? Where do you bollard? Where do you put wheel spots? How do you do appropriate signage? How do you enforce that? Little small details are oftentimes the devil's in the details, and that's what we're encountering. This is the map that we've done for San Diego here. This is our short-range plan for where we are deploying infrastructure, hopefully by the end of this year. So every one of these orange circles represent a charging spot, or a cluster of charging spots. And then this is an example of kind of the flow process. I want a charger. What happens? I need to call a certified electrical contractor. They need to come out and do a home inspection. They then need to pull a permit. They need to then install the charger, certify it. How do we streamline this process and make sure there's continuity amongst cities and jurisdictions? That's a very important part of that consumer experience. But let's be honest, there's going to be tremendous amounts of grid impacts. Typical EV can charge up to 6.6 kilowatts. You're seeing the Nissan Leaf charge at 3.3. You're seeing the Ford Focus charge at 6.6. The iLeaf charges at 6.6. That's a lot of juice. Typical home uses about 3 to 5 kilowatts. So you're essentially doubling up the power consumption at every home that you install in an EV. And what are we going to see? We're going to see clusterings. We're going to see big places like this, where you're going to have a cul-de-sac and one person gets an EV, kind of like the Prius movement. The next thing you know, a cul-de-sac with 10 homes, you have 2 EVs, 3 EVs, all running off a couple different localized transformers and distribution stations. So we need to make sure that we are having the intelligence to communicate with utilities about where this load is going to go, and also to communicate with the consumer about how they can save energy and how they can perhaps be on a demand response program. I mean, from our perspective, if you're not already attuned to your energy usage, and most people in California see 300% spikes during peak months, when you get an EV, you're going to become highly attuned to your energy usage. So what are we doing? We're deploying smart chargers. There's a big difference there. Our company is a little bit different from everyone else. We will not deploy a dumb charging station. Our CEO has said that at every conference he speaks at. We will not deploy a dumb charger. That's a charger with an on and off switch. Green light and a red light. That's not what we want to do. We will never deploy a level 1 charging station, a 110 volt outlet. Charge a Nissan Leaf off 110 level 1 outlet, 25 hours for a full charge. That's not a very good consumer experience. And from a utility perspective, you can't really control that charge window. What we're doing is creating level 2 chargers. This is our home wall mount. This is our level 2 commercial pedestal, and that's our DC fast charger. These level 2 units really are the crux of our network. We would say probably about 95 to 97% of all chargers deployed in the next 4 to 5 years are going to be level 2 chargers. In our EV project, for example, we're deploying about 250 DC fast chargers to about 13,500 level 2 chargers. Put that ratio in perspective. But these chargers need to communicate with the utilities. So all of our chargers, we've kind of future-proofed here. LAN, CDMA, Wi-Fi. We have AMI cards right now with Silver Springs. We're working with Elster. We want to be able to integrate into the AMI system. We want to be a smart end node for the smart grid. We have a certified utility grade meter. Now, you're going to hear a lot of people say that. We have a real utility grade meter. This is a billing meter inside. The only difference with this meter is ANSI C12 certified. That's not under glass. That's it. But if we have a utility grade meter, if we have communication capabilities, get real-time data from these chargers, we're essentially creating smart meters pre-packaged that can charge your car. And that these smart meters can meter essentially the entire garage onwards. So that's a house worth of load that we're able to control. Programmable charge time to be set with time of use rates. Obviously, we want people to charge off-peak and most often at night. ADA compliant. Smartphone, internet controls. What we've been developing right now we're deploying a lot of these chargers, essentially in a beta format, is that we have web portals in which someone can look at their energy usage. They can see the status of their charge at home. They can even control their charger from their laptop, smartphone, or iPad, or whatever you may have. When it comes to the commercial charging station, we're building out a whole network. So we want users to use our commercial charging stations to know where a charger is, to be able to reserve time at a charger. I'm going to go play Torrey Pines this weekend. I know my tea time's at 1. I'll probably get there at 12. Let me charge my car for 4 hours and get back home. We want to enable those types of transportation patterns amongst consumers. But you'll also see we have payment gateways. We want to create a sustainable model. We have smart grid interfaces. We are really trying to make sure that these chargers are part of the solutions for utilities and not part of the problem. So what we've done, again, mobile devices, web tools, connected devices. This right here is, I believe, the Cisco Home Energy Controller, which I'll talk about in a little bit, but making sure that our chargers are integrated in the home, that the user can have one central spot to see all of their energy use, we believe is very, very important. Again, these EV drivers become very attuned to how they're using their energy. And if they can give them an easier way to understand that usage, and also a portal for ourselves and utilities to potentially offer some price elasticities. They say when you charge off-peak at this rate, you're going to get a 3-cent rate. I know San Diego Gas and Electric has applied for a 4-cent off-peak EV rate versus their 12 to 14-cent on-peak rate. So we're seeing those types of economic factors really stimulate consumer behavior. But we believe that this whole part of this network, and that's really one of the biggest barriers to entry for an EV supply provider, is what's going to be making the difference between a smart charger, a dumb charger, a bunch of load generating devices that don't communicate versus an intelligent grid.